The p-value for a hypothesis test is shown. Use the p-value to decide whether or not to reject the null hypothesis. We're going to look at three cases, three different levels of significance. The first one we're going to look at is when alpha equals 0.01. Now let's remember our decision rule based on p-value. If the p-value is less than or equal to alpha, then we're going to reject the null hypothesis. If the p-value is greater than alpha, then you're going to fail to reject the null hypothesis. So let's look at our example. Our p-value is 0.0461, and we're comparing it to alpha. Now, what sign can I put in between those two? In fact, I would put that the p-value is bigger than alpha. Therefore, we would fail to reject the null hypothesis in part A. Now let's look at part B. In part B, we're going to look at a level of significance of 0.05. We're going to do the same thing. We're going to compare our p-value and our alpha. What sign can I put between those two? In fact, I would put that the alpha, or that this level of significance, is bigger than the p-value. Therefore, that would fall under the first category. So we would reject the null hypothesis. And let's look at part C. In part C, I want to look at an alpha value of 0.10. Okay, which one is bigger? Alpha is bigger than your p-value, therefore you would reject the null hypothesis. In this example, we're going to find the p-value for the hypothesis test with the standardized test statistic z. Then we'll decide whether to reject the null hypothesis for the level of significance. So the first thing I'd like to do is I'd like to draw a standard normal curve and plot my z-value on that graph. In this particular problem, I'm told that it's a left tail test. That means that this right here will be my p-value. So we need to go to our standard normal curve or standard normal table and find the area to the left of negative 1.32. Here's my table, and you can find this table in the back of your book in the appendix, and we're going to look for negative 1.32. Okay, there's my negative 1.3, negative 1.32. So where they intersect is 0.0934. Therefore, this area right here is 0.0934. Now I'm going to compare my p-value with my alpha value, or my level of significance. Okay, which one is bigger? The level of significance is bigger. Therefore, you would reject the null hypothesis. And now let's look at the second example. We're looking at a two-tailed test. My z-value is negative 1.68 and my alpha value is 0.05. Again, let's look at a normal curve. Let's graph this real quick. So I have negative 1.68, and I'm going to shade this area right here. Now, one thing that you want to remember is that this is going to be a two-tailed test. What does that mean in regards to your p-value? Whatever area you find here, the p-value is going to be twice, because we're talking about a two-tailed test. So whatever area you find, take that area and multiply it by 2. That's going to be your p-value. Now let's go to our table to find the area under the curve to the left of negative 1.68. Here's my curve again. I'm looking for negative 1.68. Negative 1.68. So we have 0.0465. So this area is 0.0465. So the p-value is twice 0.0465. And that is 0.0930. Now let's look and compare our p-value versus our alpha value. You can see here that your p-value is greater, therefore you're going to fail to reject the null hypothesis. Up to this point, we've been talking about p-values, but now let's switch gears and talk about critical values and rejection regions. Find the critical values and rejection regions for the type of z-test with a level of significance. Include a graph with your answer. So the first thing I want to do in this first example is to draw a picture. This is going to be a left tail test, and alpha is 0.03, which means that the area under the curve is going to be 0.03. Now what we want to do is we want to find what the critical value is, and the critical value is that z-value that corresponds to the area of 0.03. Let's go to our chart. Here's my chart, and what I'm going to do is I'm going to look in the body or in the middle portion and try to find the value that's as close to 0.03 as possible. So as I'm looking, I notice this value right here, 0.0301, and that's about as close as I can get to 0.03. So the z-value that corresponds to that is negative 1.88. So again, the z-value that corresponds to that area of 0.03 is negative 1.88. So what I would say is that this area here is also called the rejection region. That means that when I find my test statistic, if that test statistic falls somewhere in this range here, in this shaded region, we would reject the null hypothesis. So we can say that the rejection region is if z is less than negative 1.88. Now let's look at the two-tailed test. Alpha equals 0.02. Now when we're graphing our standard normal curve, the one thing I want to recall or remind you of is that this is a two-tailed test. This is not a one-tailed test. This is a two-tailed test. So when you're thinking about your alpha, this alpha is both areas here combined together. So in each of these would be half of the alpha. So in each of these, we would have 0.01. That would be the area in each one of them. Now, since your standard normal curve is symmetric, all you need to do is find one of them, and you have found both of them. One will be negative and one will be positive. So we're going to go to the chart, and we're going to look for the area of 0.01. Now again, I'm looking in the body. I'm looking in the inside of the table to find that 0.01. The thing that's closest to 0.01, and that is going to be 0.0099. That is as close as I'm going to get to 0.01. So the corresponding z-value is negative 2.33. So one will be negative and one will be positive. So how would I state my rejection region? Remember, my rejection region would be if z falls in any of these. So you could say if z is less than negative 2.33, or if z is bigger than 2.33.